Hello, my dear students, and in this session we are going to discuss about exploring magnets. In this, we are going to discuss about very short answer questions and long answer questions and some MCQs. Let us start now. What materials are attracted to magnets? Iron, nickel, cobalt, and one more is there. What is that? Steel. And these are the magnetic materials which attract. These are the metals which are attracted by the magnet. Name a non-magnetic material. So that is wood, plastic, or you can say rubber. What are the two poles of a magnet? Here we have the two poles are north pole and south pole. Next one is, why do iron filings stick more at the poles of the magnet? Why? Because at the poles of the magnet, here we have two ends. One pole is we called as north pole and other pole is we called as south pole, where the magnetic strength is more. So at this pole, the strength of the magnetic strength is more. So this is because all iron filings are attract more at the ends of the poles. The magnetic force is strongest at the poles. That's why iron filings stick more at the poles of a magnet. Is it clear, everyone? Okay. And next one, move here. And why do what directions does a freely magnet? Now you see here, question number 4. Everyone, please look at you. Everyone, please look at you. Why do iron filings stick more at the poles of magnet? Just now we completed. Why? Because magnetic force is strongest at the poles. What directions does a freely suspended magnetic point towards? North south direction. Okay. So when you suspend any magnet, though, then what happens? This magnet suspended. When you hang this magnet like this, and it will show the north south direction. Right. Now, what device helps find direction using a magnet? What device helps find what device helps find directions using a magnet? That is magnetic compass. So to find the directions, we can use magnetic compass, and for navigation also we can use magnetic compass. Okay, when you travel in sea or in ocean to find the directions, we can use this magnetic compass, and also we can use for it navigation. Is it clear, everyone? Okay. So now you see here, what is the purpose of red painted end of compass needle? So it indicates the north direction. Always remember, when this is a magnetic bar magnet. So this north direction and this south direction. So north always remember that. So north always be indicated with the red color and south we always indicated with the blue color. Okay. And next one is, what is Matsya Yantra? An ancient Indian navigation tool similar to the compass we call as Matsya Yantra. So it also in ancient times our ancestors used this Matsya Yantra to find the directions. How can you make a simple compass at home? Use a sewing needle, cork and water. By using these things we can make the sewing needle. So you take sewing needle like this. Okay. So this is the needle. Just you magnetize with the north pole of the magnet. You rub with this magnet here. So just you rub in the same direction by using the north pole. Sometimes you rub like this, and this needle will get magnetized. Afterward, you take this needle and just insert in one cork ball and place it in the water. Then it will show the north south direction. Okay. What happens when you rotate a compass and let it go? So it settles back to the point north south. Okay. So when you leave the compass for like that, so it will show which direction? North and south direction. Now, what happens when opposite poles of two magnets are brought close together? Can you tell the answer? When you brought the north to south or south to north, that two opposite poles attract each other. Okay. They attract each other. They attract each other. What happens when opposite poles of two magnets are brought close together? They attract each other. Which materials are attract to magnets? Iron, nickel and cobalt. Okay. So to remember this, I have one quote for you. Right? I can see Nick means. So what this I indicates? I indicates iron. What C indicates? C indicates cobalt. Okay. And C indicates steel. Right? And Nic indicates nickel. Okay, and these are the materials attracted by the magnet. By using this code, you can easily identify, right? Remember. And how can you identify the north pole of the magnet? It is often labeled N or made with the white dot. When you see the bar magnet, and this bar magnet is made with one dot, and this dot indicates north pole. What is the result when like poles of magnet are near each other? Already you know that when north pole is brought nearer to another north pole of another magnet, so they will repel each other. So due to this, these two magnets move far from each other. Is it clear, everyone? Okay. And now, what is a common application of magnets in game? So this is, we have one magnetic mesh. By using that magnet, we can move the steel balls, right? So this is a magnetic mesh. It is there in your textbook also. You see that. Okay. So now, how can all of you please come to the question number 16? Everyone, please. How can you lift a steel paper clip from a water using a magnet? Okay. So this is a water glass, right? Let us say here we filled with water, and now you assume that here we have one clip, right? So one pin is there. Then how do you lift this pin? By using the magnet. So when you place the magnet here, so this pin will attract towards the magnet. When you lift this magnet, along with this pin also come towards in upward direction. In this way we can remove the pin from the water. Okay. Now see here, what should you avoid to keep magnets safe? Okay, to keep the magnet safe, we have to keep the magnet from the heating. We have to keep magnet far from the heating and dropping, and we should not hammering it. If you hammer, then what will happen? The magnetic material loses its magnetism. Okay, you should not hammer it, and also you should not drop it also, and you should not heat it also. When you do all these things, what happens? The magnetic material loses magnetism. Yes or no? Now you see in the question number 18, how can magnets be used to make objects float? By using opposing magnetic forces. Okay. Then when you keep, suppose for example, here we have one north pole. Listen, everyone. So this is a ring magnets. Magnets are in the different shape, right? Okay. So when you insert in the pole, everyone, please have a look at you. So when you insert pole in like this, okay, you place another magnet with another direction. Let us say one more magnet, one more ring magnet is there like this. Okay, when you place like this, and let us assume these both sides are faced towards north side, then this north get repulsed, and the upward magnet is there, right? It will go and fly up, right? So in this way, magnets. Now you see in the question number, how can magnets be used to make objects float? By using opposing magnetic force. And this north pole opposing for like charges, and because of this like charges repulsive forces arises, and this magnetic material is repulsed by another magnetic material, and it will come in upward direction. So it looks like this object is floating on another magnet. Now you see, what type of devices should magnets be kept away from? And all of you please see the question number 19. Question number 19. What type of devices should magnets be kept away from? Okay, you should keep away electronics like mobile phones. Okay, what happens when you keep the magnets nearer to the mobile phones? It will lose its magnetism. Okay, it will lose its attracting power, right? You should not keep your magnet nearer to the mobile phones or any electronic devices, right? What is a compass used for? Compass is used to show the direction using a magnetized needle. Compass has some one dial-like structure, so it is a compass, right? And here we have some dial-like pin is there here. Okay, so have you seen this anywhere? Right? So this side we indicates north pole, and other side indicates south pole. This pin indicates north, and this side indicates south. Okay. Now extra questions we have here. Now you see here, what are magnetic materials? Magnetic materials are those that are attracted towards a magnet, such as iron, nickel, and cobalt. Okay, when you take iron, nickel and cobalt, when you take it nearer to any magnet, and these materials are attracted by your bar magnet or any shape of magnet, right? So what happens when a magnet broken into smaller pieces? Now you see, when magnet is broken into smaller pieces, let us say this is a bar magnet. So when it is broken here, then each piece will make another. So let us say this is a north pole and this is a south pole. When it is broken here, then what happens here? You see, just you see what happened. And this is a south means here you will get north. It is a north means this side you will get south and this you will get north pole. Okay, so when a magnet is broken into smaller pieces, again each piece become a new magnet with its own north and south poles. Okay, so when you drop it or when you broken this magnet, every magnet again it will divided into new magnet and also have the two ends with the north pole and the south pole. Is it clear, everyone? Okay, and next one is, now look at here. How can you identify the north and south poles of a bar magnet using the another magnet? Okay, how can you identify the north and south poles of a bar magnet using the another magnet? Suppose I have given one magnet to you. So you don't know which one is the north side and which one is south side. And I given one more magnet like this. And in this magnet we have the marking. North direction is there, south direction is there. Then how do you mark the magnet which is not having any marking? So then what you have to do now? What you have to do now? Just you this magnet, that blue color magnet, you take it nearer to the red magnet. Let us say if you take it here, then let us assume that, and these two magnets are attracted. Attracted means this end we called as what? This end called is south pole. So when you take it here, let us assume, and this magnet is attracted by another magnet means this end is south. The other side will be how much? No, the other side will be what? That is north pole. So in this way we can identify. Let us assume now it is north, south and north. So let us assume if you take this blue color magnet to red color magnet, let us assume now it is repulsing, means it is not coming closer to this magnet. That indicates what? Already it is north pole. When north pole is coming, bring to the another magnet of the north pole, then it will get repulse. If repulsive forces is arising means this side we called as what? North, and this side we called as south. So in this way we can mark the north pole and south pole for unknown magnets. Now you see, next one is, why is it important to store magnets with unlike poles facing each other? Okay, so why is it important to store magnets with unlike poles facing each other? Okay, now, so to store the magnets, always remember, you always keep north to south, again south to north like this. Okay, in between you keep one wood. Okay, then you keep it in box. So in this way you have to store the magnet. So the answer is, you see here we have the four options here. To increase their magnetic strength, option A, and the option B is to prevent the magnets from losing their magnetism, and option C is to make the magnets stick together, and option D is to keep the magnets clean. Dear students, just pause the video and try to guess the answer. Yes? Yeah, guess the answer. Yes, you are right. The answer is B, to prevent the magnets from losing their magnetism. Here we have an explanation also. Storing magnets with unlike poles facing each other prevents them from losing their magnetic properties. Is it clear, everyone? Okay, so next come to the next question, question number 5. Why do like poles of two magnets repel each other? Okay, why north repel each other? Like why south repel each other? Like poles of two magnets repel each other due to similar magnetic field lines that exert a repulsive force. Okay, so that means here north pole and another north pole, and these two north poles are giving two similar magnetic field lines. Because of that, repulsive forces arises, and this we will study in the next class. In 10th class we can study this in detail. Now come to your question number 6. What materials can block the magnetic effect between a magnet and a compass needle? What materials can block the magnetic effect between a magnet and a compass needle? Okay, so what are the materials can block the magnetic effect? Those are the non-magnetic materials like wood, plastic and glass do not block the magnetic effect. Okay, which the materials which do not block the magnetic effect, those are wood, plastic, glass. Why? Because they do not attract by magnetic effect. Next one is, and what is magnetic compass made of? Now you see, this is a magnetic compass. Everyone please look at here. Now you see, what is a magnetic compass made of? A magnetic compass consists of needle-shaped magnet mounted on a pin that can rotate freely, indicating directions. Now you see, here we have one pin. That red color marking indicates which direction it is? North direction. Yes. And the other side indicates south direction. Now you see, this is the 0 degrees and other side will be how much? 180 degrees. Okay, this will indicate the north pole and the south pole. How does a freely suspended magnet behave? When you suspend a freely magnet, and it will align itself in the north-south direction due to Earth's magnetic field. Okay, why it is aligned towards north-south direction? Because, for example, it is the Earth. Let us assume this is the south pole of the Earth. Okay, and this is north pole of the Earth. Okay, let us assume this is a spherical ball is Earth. When you hang the magnet, then what happens? This magnet align itself in the direction of like this, north and south. Why it is aligned like this? Means this north pole of magnet attracted by this south pole of the Earth. Similarly, and this south pole of the magnet attracted by north pole of the Earth. Okay. So in this way, the freely suspended magnet always align itself in the north-south direction due to Earth's magnetic field. Okay. This, what is your bar magnet you are taking? This north pole of the bar magnet attracted by south pole of the Earth. Then south pole of the magnet is attracted by north pole of the Earth. Okay. In this way, this is the reason behind this. That's why the freely suspended magnet always aligns itself in the north-south direction. Is it clear, everyone? Okay. Now you see here, how does a freely suspended magnet behave? A freely suspended magnet always aligns itself in the north-south direction due to its magnetic field. This is over. Now you come to your question number 9. What is the significance of the poles of a magnet? The poles are where the magnetic force is strongest, with maximum attraction or repulsion occurring at these points. Okay, and when you see any magnet has two poles, right? What are the poles? North pole and south pole. Okay, when you sprinkle any iron filings, the more iron filings attracted towards north pole and also towards south pole. Very little particles are attracted middle of the bar magnet. So why it happens like this? Why? Because ends of the magnet has two poles and it is having more strength, that is more magnetic strength. Because of that more magnetic strength, so it will attract more iron filings at the poles whereas compared with the middle of the magnet. Okay, and where middle of the magnet has a weak force. Okay, here we have the weak magnetic force, whereas end of the magnet has strong magnetic force. So for this reason, many iron filings attracted at the ends of north and south pole. Now you see, what are the non-magnetic materials? Already we discussed this. Non-magnetic materials are plastics, wood, glass. All these are non-magnetic materials. Here we have some MCQ questions based on your understanding. Please give the answer. Which of the following materials is magnet? Can you tell the answer? Which of the following material is magnet? Yes, wood, plastic, iron, glass. My dear students, which one is the right answer? Iron. Very good. This is iron. Nice. Next question. Can you give the answer to the next question? So here iron is a magnetic material, so it means it attracts the magnets. Okay. Now you see, oh my God, already it is visible. Okay. No problem. Now you see what happens when you bring the north pole of one magnet close to the south pole of another magnet. Yeah, the unlike poles attract each other. The answer is B. They attract each other. When north pole of the one of the magnet is taken towards to the south pole of the another magnet, the unlike poles attract each other. Similarly, north to north repel each other. North south attract each other. These are the unlike poles. They attract each other. But north to north they repel each other. Is it clear, everyone? Okay. What kind of magnets were used by sailors in the olden days? Okay, that is A. Artificial magnets. B. Lodestones. C. Electromagnets. D. Temporary magnets. Very good. The answer is lodestones. Your answer is lodestones. Sailors in the olden days used natural magnets called lodestones for navigation. Lodestones are naturally magnetized pieces of mineral magnetite which align themselves with the Earth's magnetic field, helping sailors find directions before the inventions of the modern magnetic compass. Okay, and these also behave like as magnet only, lodestones. Next one is, okay, now you see this. Which of these metal is not magnetic, sorry. Which of these metals is not magnetic? Option A, iron. Option B, nickel. Option D, option C, cobalt. Option D, copper. Can you tell the answer? Iron, nickel, cobalt are the, already you know that is magnetic materials. Okay, and the copper metals which do not attracted by magnet. This is also metal, but this copper metal do not attracted by magnet. Okay, the answer is copper. So now you see here, among the given options, iron, nickel and cobalt are magnetic metals, meaning they can be attracted to magnet. Copper on the other hand is non-magnetic. It does not interact with the magnets in the same way, making it a non-magnetic metal. Okay, remember. Now next question is, yes, what was the ancient Indian navigation device similar to the modern magnetic compass needle? Our ancestor used a Matsya Yantra as a compass needle. Now we are using the compass needle. In modern days we are using compass needle, and in our ancestors used this Matsya Yantra. Now one more question. Yes. Now you see the Matsya Yantra was ancient Indian navigation device that works similarly to the modern magnetic compass. It was used by Indian sailors to find directions while navigating on the seas, long before the magnetic compass was commonly used in Europe. Now the next question we have here. When a piece of wood is placed between a magnet and a compass needle, what is observed? When a piece of wood is placed between a magnet and a compass needle, what do you observe? The option A is the needle deflects more. Option B, the needle deflects less. Option C, there is no appreciable change in the deflection. And option D, the needle stops deflecting. My dear students, can you guess the answer? Yes, the answer is C. There is no appreciable change in the deflection. Okay, when you put any non-magnetic material between any two magnets, there is no change. Okay, there is no appreciable change in the deflection. Okay, is it clear? Look at the question number 7. Which shape of magnet is commonly used in magnetic compass? Can you guess the answer? Yes. Which shape of magnet is commonly used in magnetic compass? Very good. The answer is needle shaped magnet. Now see the answer. Needle shaped magnet, like this. Okay, so this is a needle shaped magnet. So where this one we can use in the compass. The magnetic compass typically uses a needle shaped magnet. Okay, it indicates the direction. The red color point towards the north side and the other side is south. Okay, move on to the next question. Now see here, which of the following is not a correct property of magnets? Not, he had given not. Magnets have two poles in option A. Option B is magnets attract all materials. Option C, like poles repel each other. Option D, magnets can be used to find the direction. Which of the following is not correct of property of magnets? So option A is correct. Magnets have two poles. That already you know that. Magnets attract all materials. Is it correct? No. Why? Because magnet do not attract all materials. Here given magnet attract all materials. This is not correct property. Next option C, you see like poles repel each other. That is correct only. Magnetics can be used to find the direction. That is also correct. So which one is not correct property of magnet here? That is option B. Magnets attract all materials. Magnets do not attract all materials. Magnets attract only some materials only. Okay. Now the next question. Now see here, which pole of Earth magnet is near the geographic North Pole?
South.
That is South Pole. Which pole of the Earth magnet is near the geographic North Pole? That is South Pole. Okay. Now see the reason. The reason is the Earth magnetic South Pole is near the geographic North Pole. Already I have explained this. What is the purpose of dial in the magnetic compass? Already the answer is visible. Now you see what is the purpose of the dial in a magnetic compass? So this is to indicate the directions. The dial in the magnetic compass is marked with the cardinal direction north, south, east and west. It rotates with the magnetism needle and helps the user determine the direction. They are facing by aligning the needle with the dial marking. Okay, and these are some important questions from exploring magnets. Thank you for watching. Bye children. Please subscribe. Bye.